Hey everybody, Jeff Scott coming back at you. In this short video, I want to continue our discussion on Fisetin. We've talked about what it does. You know, it's an antioxidant, anti-tumorigenic, it's senolytic, it's anti-inflammatory. We can say all those things and we can read about all over the internet those things, but what I want to talk about today is how Fisetin works at the cellular level. Let's dive in. Yeah, so I want to start this slide run with just reviewing what Fisetin is and show you the chemical structure. Again, it's a flavonoid polyphenol, and there's many types of flavonoids out there, and they all do some similar things, and then there's some unique qualities to each of them. You know, Fisetin has antioxidant properties. It's got some anti-tumorigenic properties. Of course, what I'm most interested in is the senolytic activities of Fisetin, and it's also got some anti-inflammatory properties. And the mechanisms of how it exerts these effects, there are some redundancies. You know, the senolytic effect of Fisetin also can facilitate its anti-inflammatory properties. But that's another video for another day. We're definitely going to delve into that. And the ring structure of Fisetin, this is a very stiff molecule, and it's very planar. And that allows it to do some things on the antioxidant front as well. And in fact, many flavonoid polyphenols can exert their antioxidant effects just based on their physical structure. And again, that's another video for another day. We're definitely going to dive into that. So where do you get Fisetin, right? It's almost in every plant, vegetable, many fruits, and in fact, the highest concentration of naturally occurring Fisetin occurs in strawberries. And simply adding these components, so strawberries, persimmons, cucumbers, a lot of leafy vegetables, all have reasonable quantities of Fisetin within them. So adding those type of foods to your diet is certainly the first step I would take in terms of, you know, trying to capture the antioxidant, anti-tumorigenic, senolytic, and the anti-inflammatory benefits of Fisetin. Okay, the question is the bioavailability, and that's something we'll talk about down the road. But in terms of its senolytic capabilities, you know, senescence, as we've already discussed in some other videos, is stable cell cycle arrest. Okay, the cell it changes shape a little, but it lives in perpetuity. Okay, it metabolizes, it respirates, it's consuming nutrients, it's also cranking out some immune factors that promote local inflammation. And so what we want from a senolytic compound is to jar this senescent cell out of senescence down into a pathway where the cell is eliminated or effectively dies, right? And that process is called apoptosis, okay? Apoptosis is programmed cell death. It's a very natural occurring phenomenon. When a cell accumulates DNA damage, whether through telomere shortening or exogenous reasons such as UV radiation or some sort of chemical insult, or, you know, mutations in various regulatory genes, the cell, instead of moving into a senescent state, will move itself into a path of apoptosis. So, you know, it starts the cycle here. It starts with just some changes in the DNA. It really starts hypercondensing that DNA, and the DNA starts to degrade, and you get this kind of what they call blebbing and collapse of the membranes, and ultimately all these particles, really the cell is just kind of falling apart, and then some other cells come in and clean up the mess in the end. So what we want to do with our senolytic compound is push these senescent cells into an apoptotic pathway so that the cell dies, and it stops that cell that's doing nothing for us other than consuming valuable nutrients and secreting hyperinflammatory factors that result in local inflammation throughout our tissues. We want to push that cell and get rid of it. So we want to push it into the process of apoptosis. Okay, so with that definition out of the way, I've only got one more slide for you today, and it's going to be a little bit complex, but whenever I hear people talk about the benefits of Fisetin or quercetin or any of the other myriad of polyphenols that are available that have some of these effects, they just kind of say they have the effects, and I'm kind of a how guy. I want to know, when I ingest this compound, how are my cells reacting to it? What is it doing for my cells, from a biochemical standpoint? And with this next slide, I'm going to show you this very complicated cascade of cell cycle regulation. So it's called the PI3K AKT mTOR cascade. So the PI3 portion of this is right up in here, and this is a kinase cascade. The word kinase just means phosphorylation. Okay, that kinase is an enzyme that phosphorylates one molecule, effectively activating it. So the phosphoinositol 3 kinase means it phosphorylates a phosphoinositol molecule at the third hydroxyl position. Okay, and here you get this PDK1 ultimately, and you get a little tiny phosphate group. So that is active now. Okay, and then that exerts a phosphorylative effect on AKT. Okay, so AKT's kind of the heavy hitter here. It's kind of the big player from everything I've read, and it controls a lot of different processes in the cell cycle. So without the phosphorylation of this AKT, you limit all of these downstream processes, because all of these are dependent to some degree on the phosphorylated version of that AKT. Okay, and then in the normal or in a situation where this cascade is functioning the way it's designed to function, it promotes cell survival. It promotes cellular proliferation. And in certain instances, that's fine. Okay, that can be just a natural part of the cell cycle. But in a situation where you've got a cancer that is, in a hyper growth phase, oftentimes it's this cascade, this AKT molecule moving, acting on the mTOR. And mTOR stands for mammalian target of rapamycin, which is a commonly used drug to slow the progression of cancer. And this is where that drug would be acting, okay, rapamycin. Okay, so that's just kind of an overview of this pathway. So where is Fisetin thought to act? And it's right here in this PI3 pathway. It prevents the phosphorylation event here. So this PDK1 never gets phosphorylated. And without a phosphorylated PDK1, you don't phosphorylate AKT, and you eliminate all of these downstream functions, or certainly most of them. So it's thought, from the research that I've gathered so far, that that is how Fisetin is working in our cells to move the cell out of a growth phase, a survival phase, right, which is essentially what senescence is, and move it into an apoptotic cellular death pathway. I hope that video was helpful. I hope I was able to simplify that complex biochemical cascade that was depicted in that diagram. And that's just one cascading pathway that influences the cell cycle. You can imagine when you have multiple cascades that all interact in some fashion, in some way. You can see how complex this can get, and I'm pretty confident moving forward what you're going to find with Fisetin or quercetin or any other of these flavonoid polyphenols, that there are multiple mechanisms that they disrupt beyond the PI3K that I talked to you about today. So as soon as that information comes about, I'm going to be the one to bring it to you. So if you have an interest in adding a Fisetin product to your supplemental regimen, check out the link in the description from my friends at Life Extension. They've got a really nice product specially formulated to improve bioavailability, to ensure that your cells are getting the concentrations of this powerful senolytic that your body needs to get rid of those nasty zombie cells that are causing all sorts of trouble and inflammation. So thanks for watching. Certainly appreciate it. Stay regenerative, my friends. See you soon.